My name is Patrick Carroll. I'm Association Henry J. Lyons Architects. I'm going to give you a brief overview of how, closer to the mic, how we utilise the use of BIM, particularly at design stage in the development of the project. The presentation is going to start off giving a little bit of a background to the project, to give a little bit of context to what we're trying to achieve. We'll move into BIM standards at design stage, look at the use of BIM in the structural design, the sustainability strategy, and then move on to the development of the facade, and then come back on our lessons learned.
What we could do is we could go to if you want to, we could just look at your technical condition, find something, and do the third next presentation.
Yeah, here we go. I think there's one very large image, maybe this one or the next one that's maybe throwing it out. The central bank, as we all know, have an iconic headquarter building, existing headquarter building in Dame Street. They took the bold decision to move on, to move into a new state-of-the-art facility. That state-of-the-art facility they chose a building, an existing structural frame, which is located in just up the road here on North Royal Quay. It was the home of a proposed home for the Anglo-Irish Bank headquarter building, and there was an existing structural frame built back in 2007. It comprised of 8 stories over 2-level basements. It had approximately 37,000 square meters of gross floor area. The new building was very aspirational in terms of its design. We're particularly on the sustainability aspects. We're looking at BREEAM Outstanding, BR rating of 82. Just a bit of a background on terms of the design. The design was procured through an international competition in 2012, and the construction was to be procured under a government form of contract, GCC Employer Design, which again put a lot of stipulations and requirements in terms of our design deliverables at the end. Okay, so the existing structural frame, it comprises of 2 wings, either side of a central atrium, rising from second floor right up to roof level. It was quite complex in terms of its design and limitations. The original design comprised of a fully glazed twin skin facade with an interesting servicing strategy. The service engineers were using multifunctional beams to deliver the heating and cooling loads. As a result, the ducting requirements to those beams was significantly reduced, so the existing ducts rising up through the building was limited. So we needed to capture exactly that information. We needed to know, what space was available to us pushing on in our design. So we procured a point cloud survey, which led to the development of a BIM model. Again, this was highly detailed. It contained all the relevant openings, and from accessibility and also from the ventilation. As I mentioned previously, the building was procured in 2012. So I suppose if you just ask yourself, in your own BIM journey, where were you back in 2012? And then that would kind of maybe give you an understanding of where we were coming from as well. The client requested that we deliver the building through BIM. However, there was no clear definition given as to what they actually wanted as a deliverable, let alone an EIR. Each individual design team member was procured individually, separately, through an appointment with the client. So again, that posed a number of difficulties in determining what we're going to do in terms of BIM. We had won a fantastic project in a big competition. We were all very excited in terms of BIM. We all proceeded on, and very, very soon we realised that we were in trouble in terms of our own BIM coordination and aspirations. I think, the wheels definitely came off of our BIM wagon at that stage when we realised that our architectural model was reaching 2 gigabytes in size. So, we had a lot of problems at the start. That drove us to sit down, have a complete review of where we're going in terms of BIM. We developed a BIM execution plan, which gave at a high level, just how we're going to tackle BIM and the use of BIM on project. Again, this led then to a number of detailed developments, including an exchange matrix. So we looked at each stage in the project and went down through each element, the level of development on that element, and then exchanging that. So, for instance, we have a number of cross bridges in the atrium. Initially, the architect would have, developed up a structural model based on a number of sketches from the structural engineer. At a certain point, then that was taken out of the model, and the structural engineering model was inserted. So we defined that at what stage that happened and what level of detail was required. We mapped out a number of process charts, design, sustainability, structural analysis, and then gave a set of deliverables at each stage. So we clearly defined it as best we could going forward. And again, then just set a number of BIM standards, splash sheets, and a means of checking our models going with revisions, etc. So we carried out a number of structural additions to the existing frame. We were building on a podium extension to the east and to the northern sections. At ground level, the podium would form part of the urban realm. We incorporated very intensive green roof areas, and there'd be a lot of planting. We have a new car park entrance into the 2 levels of basement on the north, just off New Walking Street. And again, you can see just some of the images during the construction, which was taken by our drone technology on site. Next slide shows a number of structural alterations which were required to the existing structural frame. Again, we inherited a building which was designed for a slightly different function. It was a fully functional bank as opposed to an overview in terms of the central bank. So we did quite an intensive structural alterations. We cut out a number of large openings in the floor plates to accommodate stairs. We needed to obviously trim those out, again from a structural point of view. This analysis gave the contractor on site a great overview of, just from a construction sequencing point of view of how each individual element related to the next activity. Our own interior fit out, again, we were procured to deliver a shell and core and full fit out. So our own internal interior fit out teams, again, was utilising BIM to convey our designs to the client, to bring the client along with us in terms of showing the designs. Again, you can see some highly detailed imagery, which contained all the relevant data for us then to deliver the hardline drawings, the schedules, etc. At the end. Running across the atrium, again, we have a number of new bridges and stairs. You can just see a number of sequencing there from the architectural model, the structural model, and then just taken last week, the bridges currently constructed. The sustainability aspects of the project are very aspirational. We are achieving BREEAM Outstanding. We were shortlisted earlier this year for the Best of BREEAM Awards in London, and I'm very proud to say that we made it onto the brochure. We will be achieving an A2 rating. This is the first time in Ireland that I'm aware of that a commercial building will achieve such a rating, and we're currently 72% increase in terms of energy usage over the baseline of our building regulation requirement at the moment. And it puts us into NZEB territory as currently defined by the government. In terms of our own interactions and design team coordination, the architectural and the energy modelling was done hand in hand, and this was fundamental in terms of delivering that energy strategy. One of the unique elements of the building is its external skin, the fail. You may have seen it when you arrived in this morning, the number of triangulated panels just located up the road. This is primarily a solar shading device, which we're using to reduce the solar heat gain on the floor plates, and as such then we reduce the cooling loads on the building. That had to be worked in hand with the energy consultant in terms of getting the aesthetic requirement of the facade. So again, we did all the modelling through IES. We did thermal analysis of the various parts of the building envelope. We did wind directional modelling. I think it was shown earlier in the Autodesk presentation. I'm just going to move on then to our facade development. The facade was developed or was procured a full year ahead of the main contract package. That was due to the fact that we had an existing structural frame. The facade procurement was split into two. We initially procured the design services from a specialist contractor who would enter under an agreement with the client to deliver a detailed design and then be novated to the main contractor under government form of contract. So in terms of our own design intent or our exemplar design, we particularly used BIM on these elements to clearly define and scope out how we were going to deliver and how we were going to design the various aspects. We used a number of key modelling elements. We looked at kit of parts. Again, we were looking at off-site construction. I know it's been used quite a lot today. Again, this was fundamental to delivering the project on time and achieving a very high quality design. So again, you can see just the breakout of the various facade elements and how we're going to achieve it. The facade procurement gave us an opportunity to, particularly on the design side, gave us an opportunity to integrate BIM requirements, particularly in terms of the tender. So we set about looking at a task information delivery plan. This was based on the CIC BIM protocols, which clearly defined the roles and responsibilities of the contractor, clearly defined in terms of level of development of the various the various elements of the facade. We set a very high level of development for production information. We were looking at possibly using BIM for manufacture on the various elements. And then, I suppose, as part of the CIC protocol, Henry J. Lyons were appointed the project information managers. We set about developing a project workflow, again, just looking at the various means of which we're going to transfer the information and go about that. And also then, just from a 2D point of view, the approval process in terms of hardline 2D drawings and ABC status and what that actually meant for the contractor. Once the contractor was on board, again, we set about some, a very high level of detail. You can see here, just on a rooftop, we have a perforated metal panel screen on the roof. Again, it shows the secondary steelwork, high level, and then a photograph of the cladding, the actual cladding that went around that. The structural steelwork was developed through Tekla. The design for the paneling itself was actually 3D AutoCAD. We transferred that information through IFC and back into a federated Navisworks model. You can see some of the other elements. The central atrium, we had a vertical glazed element. it's probably unique in its use in Ireland. I think it's the first time again it's being used. It's a VS1 glazing system coming in from the United States. The panel sizes, the glass panel sizes are on the limits of what you can actually manufacture from a glass size point of view. And this posed a number of problems in terms of deflection, all of that. And then, so all that analysis was carried out in terms looking at Autodesk robotics. On the roof, we have a 3-ply glazed fin running in 2 directions, which then support a fully glazed roof. So again, we had to look at and analyse the structural design of those 3 plies, look at the redundancy. What if one of those elements actually, gave way? Is there enough redundancy in the other 2 layers? Again, just come back to our LOD, high level of production information required in the model, and the outer veil in particular. We utilised the outer veil actually to manufacture the models, to manufacture the elements. You can see the machine down in the corner is a CAM, 3D CAM machine, which was bought specifically by the facade contractor for this project. The outer skin was developed through SolidWorks. Again, it was a very hot, you can see some of the imagery there. The contractors will model literally, every single bolt hole, and element. And again, those models were fed back in through into the machine, which again gave the opportunity to push on. Again, just to show some of our modelling in terms of the facade, different panel types. On-site, collaboration and coordination, clash detection key. The top image here was fire escape routing at roof level. Again, all our major plant is located at roof level, very congested, so it was critical that we achieved the required level of detail. And then finally, just to move on to our key learnings. Number 1, first and foremost, an EIR clearly set out from a client what's required, in terms of deliverables, and then that will give the opportunity for the design team to set about delivering that. Roles and responsibilities within design team. Scope of work, again, critical, not just from a BIM point of view, but who's doing what, and then how does that relate in terms of BIM modelling. Level of development, project timelines, model standards, and then we were looking at matrix for success. So this would have been one of our very first collaborative BIM projects in the office. We've since moved on to a number of other projects. And,
Great, let's leave it there.
Yeah, great.
Okay.
So, thank you.